Okay, so thank you again. Thank you very much for joining us for today's webinar looking at structured expert judgment and advancing the science of risk assessment. So we've got a very interesting session lined up today and very keen to hear from Dr. Anca Hanea. My name is Teresa Riccio-Goodwin. I'm a fellow with the Institute of Strategic Risk Management, a globally qualified internal auditor, really selling myself as someone interesting with being an auditor, but here we are. And as part of my journey, starting in audit, moving into risk, and really a big fan of everything risk, internal control, and most recently appointed as the chapter chair for the Victorian, South Australian and Tasmanian ISRM members for those states. So very happy to be here. We'll kick off with an acknowledgement of country. So we would like to begin by acknowledging the traditional custodians of the lands on which we gather today. For me, in South Australia, it's the Kaurna people. We recognise the Aboriginal and Torres Strait Islander peoples as the original custodians of this land, and we pay our respects to their elders, past and present. So for today, we are incredibly lucky to be welcoming participants from 16 countries. So we're talking Australia, New Zealand, UK, Canada, Serbia, Saudi Arabia, Sri Lanka, India, Trinidad and Tobago, Pakistan, Ireland, Zimbabwe, Nigeria, Saudi Arabia, Czech Republic, and Singapore. And I'm incredibly grateful that I can pronounce all the countries because that makes my job a lot easier. So as we look forward, we're building that risk management village and that risk management community, and we're certainly doing so with today's webinar. So we have our moderator for today, Paul Vorbach. Paul is also a fellow with the Institute, and I'll introduce him very soon. And obviously our speaker, Dr. Anca Hanea. And Paul has the honour of introducing Anca a little bit later. So as part of our lineup for today, or what today will look like, Anca will speak for around 40 minutes. We will take some questions during the presentation and then questions and comments at the end of the presentation. So please feel free to use chat, write your question in, write your comment in, and Paul will be moderating as per the chat. We are aiming to wrap up at about 6 p.m. Australian Eastern Standard Time. So the Institute of Strategic Risk Management is a global centre where people who are passionate about risk can come together. So it's not limited to practitioners or academics, but rather a mix of practitioners, academics and policymakers. And coming together to not only share insights, but also progress and promote an understanding and capabilities associated with strategic risks and crisis management. So it's a fantastic opportunity to come together, share your experiences, share your war stories, but also really learn from each other as part of our risk management journeys. So something very exciting that happened today was the first induction meeting of the young risk professionals. So really trailblazing and giving those starting out in their career a place to go and talk about risk and get some insight as to what's happening in the big wide world. And certainly would have loved to have seen that when I embarked on my career, not that long ago, of course. So please join our community, become an ISRM member. On the screen, you'll see some wonderful benefits as part of being a member. And if we think about the ISRM academic library, and not only the quantity, but the quality of papers that are available on there, global job updates, 20% discount on the training programs, which are fantastic, but also access to the global network of risk professionals and insightful sessions such as this. So our moderator, Paul Vorbach for today, a fellow with the ISRM, as I mentioned earlier. Paul is Vice President of ISRM Australia and New Zealand, Managing Director of the AcademyGlobal, New South Wales Director for the Australian Institute of Company Directors, Paul is a wealth of knowledge, a trustee and council member for the Chartered Institute of Public Finance and Accountancy, an adjunct faculty for the University of New South Wales. So Paul's 30-year career covers a lot of information and a lot of experience. And Paul, I will throw to you.
Fabulous. Thank you very much indeed, Teresa, and good evening to those of you coming to us from New Zealand, late afternoon for most of the Aussies. Probably somewhere around about midday, I guess, for those in South Asia, and quite probably early-ish morning for most of Africa and Europe as well. So fantastic to have you all here for what I'm hoping, and I'm quietly confident will be a really worthwhile hour of your time. Teresa, thanks very much again for your introduction as well. So Dr. Anca Hanea, PhD, is Associate Professor of University of Melbourne in the Centre of Excellence for Biosecurity and Risk. She specialises in probabilistic modelling and structured expert judgment, the subject of our talk today, and decision making under uncertainty, with applications across biosecurity, infrastructure, and public policy. Anca has been designing and running structured expert judgment workshops since 2009. So what's that, 16 years, advancing both theory, but I guess for our audience, most importantly, in some respects, practice by combining applied probability, optimization, psychology, and the social sciences. Her career spans roles at the University of Melbourne and TU Delft, with teaching experience in 3 countries. She holds a PhD in applied probability, a master's degree in risk and environmental modelling, cum laude, from Delft University of Technology, and a bachelor's degree in mathematics from the University of Bucharest. So incredibly well qualified to run this discussion, and genuinely one of the world's leading thinkers, researchers, and practitioners in this field. So completely honoured and thrilled to have Anca with us. So, ladies and gentlemen, without further ado, can I please hand you over to Anca Hanea.
Thank you, Paul. Thank you, Teresa. Thank you, all of you, for the invitation in the first place, and for such a generous and kind introduction, Paul. I'm hoping I won't disappoint. I'll share my screen with the slides. Share. There you go. That took longer than I expected. And thank you, all of you, for joining us for this talk. I'm gonna go straight into it. I'm gonna talk about, like Paul said, structured expert judgment. Hopefully by the end of this talk, it will be clear what I mean by that. And this will be in the context of risk assessment and decision-making under uncertainty. As a quick outline, I will go through a little bit of the context, and by context, I mean in what context I'm using this structured expert judgment, and we're using it here at the Centre of Excellence for Biosecurity Risk Analysis, and how it was used at the Technical University of Delft when I was working there, and so on and so forth. And also what's the sort of defining context and fundamentals of what I call risk assessment and decision-making under uncertainty. Then I'll talk about the expert judgment or knowledge elicitation and the distinction between eliciting qualitative data and quantitative data and the mixture of the two, and why is this important. And I'll touch on applications, and just before that, I will probably pause for questions if there are any. But there's loads of application areas for expert judgment in general and for structured expert judgment in particular. I will only talk about 4 different types: the biosecurity type applications, because this is where I've been working in this space for 10 years, 11 years now. So these are the more recent ones. And then I'll mention the ones in engineering where I started my training in, and And natural hazards, I'll say something about an application in natural hazards, and I'll end up with an application that we've run through the a group at the University of Melbourne in social sciences, just to give you an idea of how widely this can be applied and how many variations and faces these structured expert judgment elicitations can have. And I'll just end with one slide on what sort of lessons we've learned, like the key messages that we can broadcast for other people who would like to run their expert elicitations from here on. So in terms of context, and I know this is not something that you're unfamiliar with. Everybody here probably knows what the definition of risk is in one form or another. And when I first saw the definition of, like the ISO definition, the first one on the list, you can imagine that the mathematician in me didn't really like that. I'm more of a number person rather than words. And definitions and operational definitions in general are very important for me. So I didn't know how they operationalize uncertainty or what they mean by objective. So I kept digging, found a series of podcasts very recently, actually, that you have a QR code there in the middle that I found them fascinating. And if you're not familiar with them, they're podcasts on risk analysis, risk assessment, and very interesting discussions. But a more comprehensive list of definitions of what risk is put together by the Society of Risk Analysis. And on their website, they have a glossary, and they have a list of definitions, both qualitative and quantitative, and a mixture of the two in different shapes and forms, that risk is defined and used in different application areas. And again, if you're not familiar with that, I invite you to just scan that code and have a look. Given my background, I come from a quantitative view of what risk is, and a very engineering perspective on how does it need to be operationalized in order to be useful in application and predictions and decision making under uncertainty. So I very often work with the definition of risks that answers 4 questions. And the example that I will have for this question is from a year ago, when I still had hope for the United States. So the questions that the risk framing should answer are: what can happen? How likely it is for that to happen? So put some sort of quantities of the likelihood of an event to occur. What are the consequences after it happens? And how do we feel about it? So that's the framework I usually work in. And you can see there's a mixture of qualitative modeling in terms of you have to list the events, you have to think about all the possible scenarios and their consequences. And then there's a quantitative version where you put numbers on probabilities and likelihoods, and then severity of consequences. So this is pretty much the framing of a probabilistic risk assessment that probably some of you are very familiar with, so I don't need to bang on about it, but that's pretty much where I'm coming from. Assessing probabilities of things that can occur and assessing the severity of consequences of that, it's what constitutes a risk assessment. But then when we move into the decision space, and this may be a completely artificial distinction in the academic world, and I apologize on behalf of the academic world, but very often the risk analysis sort of societies and the decision analysis societies use slightly different language and use slightly different formulations of what I think fundamentally is the same thing. So assessing risk and their consequences, and then acting on an uncertain state of the world, we don't know what's going to happen, will also affect the potential consequences. And those 4 things in general will define what a decision analysis or a rational decision-making framework looks like. Very often the same sort of concepts are used in risk management, maybe with slightly different names. So decision analysis and a risk management sort of formulation are fundamentally using the same concepts in terms of quantifying uncertainty and thinking of the severity of consequences. So that is where I'm coming from. And in those formulation and modeling exercises, if you wish, you would always look for data. When building a model will have a conceptual stage where you start drawing different variables and different influences between those variables. And that's the first step. But then you will look into parameterizing those with the numbers, like I've mentioned earlier, likelihoods and severity of consequences. And very often, not all data is there. So that is the place where expert elicitation is needed. And the way we should think about the problem, and we're often advised to do so, is use the expertise in this context that I've just described, use it wisely. And this is a paper that advises for that. That was written in 10 years ago by Bill Sutherland and Mike Bergman. It's a really nice and interesting and easy read, where they make a clear distinction between what can we ask experts about and what should we not ask experts about. So we can ask experts about quantifiable things, quantifying uncertainty, events that didn't yet happen, so we want to know what's the likelihood of that, or potential measurable quantities that we didn't have the resources to go out and measure. So facts that in principle we could ask nature, but we don't have the resources to do so. That is what we're using structured expert judgment for, rather than asking experts for what sort of decision should I take, what sort of management is more important, or what do you think I should do. So asking for preferences and asking for utility functions, for values, that is not something that we should go to experts for. That's a completely different sort of type of methodology that we should use. And for sure, you should not ask me about risk appetites. That's another thing that experts shouldn't be consulted on. So that's the context of expert judgment and expert knowledge elicitation. And the reason I'm using both is because we actually elicit both judgments and knowledge in a qualitative, quantitative format. And I'll give you a little bit of the history of what I'm talking about. So before I start with the history, that little mess of a diagram on the right corner up there is just there to remind me that what we're doing here is we're talking about structured methods. So whatever I'm going to be talking about from here on doesn't include unstructured, informal methods of eliciting knowledge, opinion, judgments from experts. So we're not talking a bunch of guys sitting around the table and just passing on numbers. That's not what we're doing here. That is, they exist. They're used a lot more often than they should. Roger Cook classifies them as being like expert judgment, being pretty much like the internet, running from sordid to sublime. We're talking about the sublime sort of end of the spectrum here, and the sordid ones are the unstructured and informal ones that we don't want to think about as expert elicitation in a scientific sort of way. So the structured ones were pioneered by the Rand Corporation in the 50s with the Delphi method. And the Delphi method uses it's asking both for estimates, numerical things from experts, but also rationales to explain their thinking behind it. In the 60s, nominal group techniques appeared more in a qualitative framework, and they were there to improve small group decisions. So they acknowledged how important the discussion, a facilitated discussion is, and people clarifying ambiguities through a discussion. In the 70s and 80s, estimate, again, it's a type of expert elicitation, mostly quantitative, that refined what we knew from a Delphi method, but we also, the Delphi method gives the experts the possibility of changing their minds after they've seen feedback from other experts, and is the same in this sort of estimate. Experts can talk to one another and understand the reasoning and clarify ambiguities, and then have a chance to change their mind. And this sort of all the methods started to get adoption in the 70s and 80s by the US Regulatory Commission, and by, NASA acknowledged the need for structured expert judgment in high-stake engineering after the Challenger disaster. The European Commission began commissioning structured elicitations for energy and nuclear safety. And there's a procedure guide for structured expert judgment that uses the method that is mentioned before, just below, sorry, in the 1990s, the Cook's classical model. So Roger Cook and colleagues from the Technical University of Delft wrote those procedures for the European Commission. And this is one of the main structured protocols that we can talk about in the expert judgment elicitation world. And it's a mainly quantitative method. It formalizes uncertainty in terms of probabilities. So it's quantifying that uncertainty using probability theory and statistics. Same with the Sheffield framework, which is a different structured protocol. I'll talk a bit more about the differences between them. And then since the 2010s, all these lessons that we've learned from the previous methods were used to create new protocols that will take different steps that we learned that had advantages and were giving us estimates that were more accurate or more calibrated or more informative, and incorporating all the lessons we've learned from previous methods. And again, they combine the quantitative information with qualitative reasoning and the quality of that reasoning as well. So there's no definition for a structured expert judgment elicitation. There's a set of guidelines that the community agrees on, and I have them listed here and split in little subgroups. The first one, it pretty much says, have clear operational definitions. Don't ask experts about something that you can't go out and perform experiments. So that have a measurable thing that you're asking about, so then eventually you'll be able to calibrate against realizations or data if they become available. The next three steps, they just describe a scientific method. So it's just have transparent methodological rules, document it thoroughly, and if possible, allow empirical control. The next two acknowledges the fact that we're working with humans and we're asking them to do a very hard thing, which is thinking under uncertainty, which is very hard. And because of that, there's going to be heuristics that people use to think quicker and to think under these uncertain conditions that will lead to cognitive biases that we may be able to mitigate against through the steps of the protocols. Including the possibility of identifying the expert speaks to accountability. We never associate names of experts with the numbers that they gave, but there will always be a place where we acknowledge the group of experts whose numbers were aggregated to produce an answer. And at the end, and I just mentioned that we need a way of aggregating. We're asking a group of experts about the same sort of questions. They will not always agree. Well, more often than not, they won't agree. So we will have to have a way of combining all those estimates into one group judgment that can be then used in the modeling. So there's lots of different, I don't know if lots, but there's some differences between the different protocols, but they come in the steps and in the way they allow people to interact with one another or provide feedback or let experts talk before estimating or after estimating. So there's things where protocols differ, but there's a few elements where the whole community agrees they're important. And the one in the title is maybe the most important. First of all, we couldn't find a way of defining a best regarded expert. So that's why that's in between quotation marks. There's no, in the context that we're talking about. So we're talking about quantifying uncertainty. We don't know who a best expert is. So then the solution for that is go for a group. A group of experts will always perform, and there's a bit of data on that. A group of experts will always provide more accurate and more calibrated estimates than whatever we mean by the best regarded expert. So we aim for a group that is diverse. We also know that having everyone think independently before talking to the rest of the group is fairly important. We want individuals to draw on their own local knowledge and then we also want them to talk to one another so that knowledge pool increases due to the diversity of the group. And we also want a way of aggregating the expert judgments, and we can do that mathematically or we can do that behaviorally. And I'll say more about that in a second. But before I do, I mentioned the fact that we're working with thinking under uncertainty, which is very hard, and we all know that. And to be able to mitigate against that is we'll have to pay attention to the way we ask the questions, the way we formulate them, the way we sequence them. And there's a huge number of bias, cognitive biases that can happen while we're trying to think under uncertainty. But we can't mitigate against all of them. We actually don't know if we can mitigate against the ones that we identify as the strongest, but we're trying to do that. One way of doing it is to make experts aware that they will happen, and through the different steps of protocols. I don't think I'll have time to talk about how we do that through the steps, but if you have any questions, I'm more than happy to tell you what are the steps that mitigate against which of the biases. And the biases that we see reoccurring most often, the individual cognitive biases, are the anchoring bias, the availability bias, and the overconfidence. And anchoring, just you have a list of examples on the right-hand side, but very briefly, we tend to be very influenced by the first piece of information, numerical information that we hear, even to the point where that number has absolutely nothing to do with the question that we're being asked. And as you can imagine, this is a bias that is very easily manipulated. So this is something that we're trying to mitigate against through the steps of the protocol. The availability bias is we tend to give more weight to events that we can recall more easy. And again, you have a list of things that can happen there. And this availability bias, again, very hard to mitigate against. But what we're doing for example, with a group discussion in a structured elicitation is we're bringing all the availability biases together. So we will ask people to cross-examine the other's reasoning, and that will bring up the potential availability biases. And overconfidence, I don't think I need to tell you what that is. And it's prevalent in expert judgments. Very often we think we know a bit more than we actually do. And that's visible when we're asked to quantify uncertainty, because we're going to be asked to provide ranges of estimates that are very often quite narrow, a lot narrower than they probably should be. Then these were the individual ones. If we have within the protocol, if there's a step that brings people together and we have a group discussion, which very often we do, there's the group biases that will show up in those discussions. And there's again a few of them. Not much to do about it. What we're suggesting is if you have discussion within a group, have it facilitated by someone who doesn't necessarily is not impressed by the seniority of the people in the room or by the egos of the people in the room. You can mitigate against it to some extent, but that's something to be aware of. There's a few books and references that talk about different methodologies and expert elicitation methods. The first one that I mentioned, the one that I said was commissioned in the 80s by the European Commission, the classical model or the Cook's model for structured expert judgment, that's described in the first book there, Experts in Uncertainty. The behavioral aggregation one, or the Sheffield method, that was also listed in the history of methods, is the third book, The Uncertain Judgments, that was written by Tony O'Hagan and his colleagues at the University of Sheffield. The one in the middle picks up elements from both, from Cook's method and Sheffield method, and puts together a structured expert judgment elicitation protocol that was developed here at the University of Melbourne and pioneered by Mark Bergman. And then you may recognize the super forecasting book, Philip Tedlock's book on how to identify super forecasters. And the last couple of books on the right-hand side, they're just more recent edited books that put together chapters on developments from the methodological perspective, but also from the application, more recent applications of structured expert judgment in various domains. So going back, the two types of elicitations, the two types of aggregations that I mentioned earlier. So we go to a group of experts, they're going to give us diverse numbers and rationales for those, and we want to have a way of putting them together, like aggregating them. So what the Sheffield elicitation framework does, and that's the one that uses behavioral aggregation, is goes to a diverse group of experts, those little colorful people there in the picture, and first of all has an independent step. It asks people to provide numbers in terms of quantifying uncertainty about facts. Like I said, they say in a biosecurity risk analysis example would be, I'm interested to see the number of passengers that would bring biosecurity risk material that would just bring it into the country. So I can go to the airports and check and see how many of them declare things, and then look at how many of them actually have apples or whatever it is that they're not allowed to bring in the country. We don't know it for next year, say, and we're going to go to experts and ask that. We are asking experts for point estimates, but we acknowledge that's an uncertain quantity, so we ask them for a range around that point estimate. So those are those lines, and the little bubble in the middle, that's the best estimate, and the bounds, possible minimum and maximum, lower and upper bounds. Now, the Sheffield method is very heavily probabilistic, and what it does, it fits distributions on each of those experts. So you have a little graph there with experts A through F. Each expert gave me 3 numbers. I fit the distribution onto that, and this is how the diversity of opinions look like. And after this stage, they are invited to talk about the differences in the reasoning behind their numbers and come up with a consensus distribution. So that's the behavioral aggregation way of doing things. At the end of the process, you end up with one of those lines, which represents the group's judgment. In the Cook's classical model, you do the same for the first step, and then there's no feedback. So the discussion happens initially just to clarify the meaning of the questions and to make sure everyone understands the questions properly. Everyone gives independent answers. Even though Cook's method is also a probabilistic model, it doesn't necessarily fit distributions. It looks at those histogram-like distributions built with the 3 numbers. And then what it aims to do is to use a mathematical aggregation, which is just an average of the distributions. But instead of using an average, or what's called an equally weighted distribution, it does an extra step. And that's the empirical control that was mentioned in one of the guidelines. And namely, it asks questions called calibration questions, for which we know the answers, or the answers will become known soon after the elicitation. And it uses those questions to see how well the experts performed as uncertainty quantifiers, if you wish. So it looks at where does that true value or realization in the picture on this slide, where does it fall within the interval? Is it between the bounds? Is it outside the bounds? We're aiming for experts capturing this realization, so that would make them calibrated. And we're aiming for experts that are informative. So having very wide bounds, very wide distributions translates into less informative or uninformative distribution. So we want calibrated experts which are also informative. We don't want answers of the sort of experts tree, which is fairly informative, so narrow bounds, but misses the realization. But of course, this is done on a long run, not on one question, but on a set of calibration questions. Now, from this, you can calculate performance score, how well they did, use that as a weight in aggregating mathematically these distributions or these numbers that the experts gave. So these are the 2 types of elicitations that are the 2 types of aggregation that are mainly used, behavioral or mathematical. What we did at the University of Melbourne, when Mark Bergman started in the 2010, is trying to pick up the good elements of this protocol. So we know diversity is good. We know independent thinking is good. We know discussion is good because it clarifies a lot of ambiguities. And we know people go back and change their mind if they misunderstood something. So we kept the independent thinking. We kept the facilitated discussion. We kept the second round of estimates after they talked, but we're not aiming for consensus. So instead of aiming for consensus, we're just doing the mathematical aggregation of the second round estimates. So this is called the idea protocol. And we can do that with or without calibration questions, so with empirical control or without empirical control. And it pretty much brings together those elements that I talked about earlier into this protocol that has a first round of estimates. Then it provides anonymized feedback plots like the one that you have in the middle. People start talking about the reasons behind the numbers and the reasons behind the potential disagreements. And if they hear anything that is convincing in that discussion, they may go and change their mind or not. So the last plot in this picture is the dashed lines are the original estimates and the solid ones are the new estimates. In this example, it's an artificial example. Everyone changed their mind. That doesn't really happen in practice, but it may. And at the end of the process, this is the last estimate that we're aggregating mathematically with equal weights or differential based on performance to create that group estimate. So I'll pause here before we go to the applications, because that was a lot of content and maybe there are questions.
Terrific. So if there are any questions, I might be self-indulgent if I can, Anca, and throw my question in first. I mean, the case to bring rigor into often very subjective, qualitative judgments seems to be extremely powerful. And I guess also that SEJ recognises that we often don't have sufficiently large data sets to use purely quantitative methods. So it brings those two things together. Given how compelling the argument seems to be, why is SEJ not used more frequently in our risk assessments, do you think?
That's a great question, Paul, and a hard one too. I think part of the problem is because it was abused, because it was misused in so many cases, and because it was not well explained in various fields. So that's one reason. Another reason is, I guess, traditional statisticians would be very skeptical about expert judgment because their whole training is based on data, and that's perfectly valid. But very often I found in my experience that when you start formulating the question that your problem owner brings to you, it's very tempting to first look at, okay, what's available, what are the models, what is the data, and slightly change that question that was initially asked to fit what you can answer with the data available. That is, I guess that's a healthy instinct because that is a solid type of evidence, and it's a bit scary to go, okay, I will give you an answer to the question you're interested in, but it will be more approximate and with more uncertainty than the one I could give you with just the data. So I don't know. It's that need for more scientific, if you wish, answers because they're based on hard data. But I have a few examples where hard data looks so much weirder than what my experts gave me because it's unreliable. It's not relevant for what we're doing. But these are not questions that are usually discussed.
Okay, thank you. Let me see what I've got. Do I have any other questions here? So Brett Dobby asks, and Brett is our Deputy Chair for New South Wales and ACT. Welcome, Brett. I'm intrigued by your inclusion of how do you feel about it factor. And does this influence risks based on the unpredictability of human behaviour?
How do you feel about it is the last question of a rational decision-making framework, in the sense that what you're trying to do in a decision-making is to estimate the expected utility of a decision, and that decision will have consequences, and the decision maker will take a decision that will have consequences, and you will have the utilities of those consequences in a mathematical framework. Those utilities are my formula for how do you feel about it. And it's true, it's a very subjective estimation. What very often happens is that how do you feel about it is quantified in terms of money. I'm not completely happy about that, but that's what expected utility is, very often monetary value.
Okay, fantastic. All right, well, just in the interest of time, I think we might push on with the last part of the application in practice too. Thanks, Anca.
Thank you. So I'll share my screen again. Okay, so like I said, I'll just zoom through a few applications in 4 different domains, staying a bit more on the biosecurity ones, because these are the ones I'm working on, and I'll talk in a little bit more detail about 2 of them that are more recent, and you'll see the reason for choosing those 2. But then we'll move to a little bit of natural hazards and a few words on engineering applications, and the last one on social sciences. So for the biosecurity risk analysis that we're doing for different sort of institutes or for the governments within the Center of Excellence for Biosecurity Risk Analysis, we're often being commissioned to do pest risk analysis or pathogen risk analysis for different sort of diseases or plant pests. And you have here on the slide a project that we worked on with the Cochrane Institute in New Zealand that was worried about a risk assessment on a disease that affected their native oysters. We had a project in the recent years with what used to be agri-research until recently on potential pests that affect kiwi fruits, and the Zespri kiwi fruit industry was interested as well in surveillance methods and how to do their surveillance better, I guess, to protect their kiwi fruit industry. The Tasmanian government was commissioned us to do a pest risk analysis for 5 of the pests that are on the mainland, but they didn't make it to Tassie yet, so I think they want to keep it like that, and they wanted advice on how to do this better. We had elicitations and other projects on foot and mouth disease for the Australian government, for the Department of Agriculture, Fishery and Forestry. And we're currently working on a project for the Department of Conservation of New Zealand on how to keep rodents out of racura. So these are just a few recent examples that we've been working on. And I'll just say a few words about the Tasmanian border biosecurity application. So like I said, it was what they wanted was an in-depth review and risk analysis of key biosecurity pathways. So how do these pests, the 5 pests that they used, then they were interested in how do they get to Tassie? What's the potential pathway of getting those into Tassie? And produce, so imported produce and pathogens moving between mainland and Tassie were the 2 main pathways that we looked at. They wanted to know what's the contamination or outbreak risk in terms of annual outbreak rate and the impact that it would have if those pests would arrive in Tassie. Try and give them an idea of how effective the biosecurity measures that they're using, either the pre-border, if you wish, border with Tassie. I mean, so the fumigation processes, for example, for produce that is shipped to Tassie, or inspections done at the airports or at the places where produce arrives. And they wanted to have some estimate of the consequences and the costs of potential future outbreaks. So we provided them with with a comprehensive, fairly comprehensive model. We started with a conceptual model, put it in mathematical form, looked for the potential data that we can use. So it was transformed into a probabilistic simulation model that was fed with, parameterized with all the available data that we can find. As always, we've identified lack of data, and especially for this sort of exercises where you have to project to the future, there's always a lack of data. It didn't happen yet. So expert elicitation was needed in this case. So we combined the two sources, came up with a few recommendations, and we provided pictures like the one that you have here, where you can look at the two dimensions that they're interested in, how much will it cost for them to eradicate if it happens, and what would be the annual outbreak rate. So we have a medfly, for example, that is very unlikely to come in, but if it does, it will cost a lot of money, and that was meant to inform the type of decisions that they need to take in terms of resource allocation. Where do they have to change or do more biosecurity, or change their biosecurity measures in order to have less impact? And one of the reasons I put this one in is because after we finished the project, the Minister for Primary Industries and Water announced a budget increase that included almost 13 million for biosecurity, and some of that money was to implement some of our recommendations. So that made us very happy. Another reason is because this is a standard this project had a standard time frame and time line in terms of what should you expect, how long should you expect the expert judgment to be. So the whole project lasted like 8-9 months. The expert elicitation part of it, so after the model was ready, the data gaps were identified, all the data was collated, the questions were formulated, it only took about 2 months. And that includes identifying the experts, making sure that you can bring them together. We used an idea protocol, so we had to have a discussion between rounds. We had to allow them time to answer the initial questions. So the whole thing took about 2 months, say, and that would be a standard way of working with the idea protocol, at least. Now, one application that instead of 2 months took about 2 days was when the department just contacted SEBRA and said, so our center, and said, we really need to redo an expert elicitation that was done a year ago, because foot and mouth disease there's an outbreak in Indonesia. We want to know how the probability of an outbreak in Australia in the next 5 years, how will it change now that it's closer to Australia? So that had to happen very quickly. And we did have a pool of participants that we had in prior elicitations. So we had access to 21 participants, which was great. We had only one question. It was really well defined, and it had a base rate that we started from. So everything was clear and short, but we didn't have time to go further and investigate or do any sort of in-depth pathway risk analysis. So it can happen in 2 days, given good conditions, but ideally you would spend more time on such elicitations. And this was again a case where we used the IDEA protocol. In terms of the engineering applications, you'll find a wealth of resources on Roger's website. So and what's beautiful about the engineering applications that use the classical model, so not the IDEA protocol, but the Cook's Delft classical model, all these names mean the same thing, is that this protocol was used unchanged since the 90s. So the database of expert elicitations with calibration questions just grows and grows, and Roger keeps them all on his website. There's also a list of publications that if you look through it, you'll see most of them will be in engineering or natural hazards. And the beauty of having so many data sets of expert elicited data is that you can do cross-validation studies. So you can prove that it actually works. So a group of experts is always better than the best expert, whatever that means. You can get more accurate answers. You can you can do all sorts of nice statistics on elicited data and prove that it's robust and accurate, and people shouldn't be scared of using it. Within that set that Roger keeps updating on his website, there's one of the longest running applications of structured expert judgment of Cook's method in volcanology, and that's done by Willie Aspinall. And I think Willie started the first application in 1997, and he's been running elicitations for the probability of the Montserrat volcano to erupt on regular basis. So that would be the longest running elicitation in natural hazards. And very quickly, the last application, the application that I will talk about it was a project commissioned by DARPA, and the University of Melbourne had a team that worked on this project called Replicats. So CATS from the Replicats stands for Collaborative Assessment for Trustworthy Science, and it was part of DARPA's SCORE program, and SCORE is Systemizing Confidence in Open Research and Evidence. So they're basically what they were trying to evaluate is or develop is tools for assigning confidence scores to research results. And that would be in the areas of social and behavioral science. So research results in our research transformed into claims. So we would look through papers and evaluate claims within that paper. And our team used an IDEA protocol with different participants. And the question that we posed to these participants was, what is the probability that direct replication of a study would find a statistically significant effect in the same direction as the original study? So that will give you confidence that what they found can be replicated. So it's part of the replication crisis sort of research. And we had the pleasure of working on this between 2019 and 2022. And it's been amazing to work with social scientists and psychologists and philosophers who look at how you formulate the questions and what people will tell you in a completely different way than a mathematician would. So that was for me, that was a very privileged role to have in this team. And I think that's it for the application. So throughout these years of applying and working with different people and in different fields and with different protocols, what we've learned, and we're very confident that we've learned this lesson well, is that always use diverse groups. That works miracles. It's always good to have a diverse group of people. Don't be starstruck and don't be bullied. These are quotes from that Mark Bergman and Bill Sutherland paper that I've showed you earlier. Don't be starstruck just means the fact that someone has a membership of lots of memberships for learned societies, a huge number of publications, a reputation, that doesn't mean that they will be good at quantifying uncertainty. Don't be bullied just means if you're in a room and you have a discussion, the fact that someone talks louder than you doesn't mean that they're right. And on the contrary, we very often find that people who are quiet and listen and assimilate the information from the diverse sources actually perform quite well in the second round. And that brings me to the use prior performance. So the only predictor that we found for how well people can do in these exercises is prior performance. If you have calibration questions, you can measure that. That is the only predictive of future performance. We found that we keep finding that training the experts in terms of the biases, in terms of what do you mean by probabilities, and how will you use those numbers, it makes a difference. It improves the accuracy and the informativeness of results. Feedback is really important, so having that anonymized feedback round at the middle of your elicitation really brings up questions of why people, like cross-examining and counterfactual thinking is brought up by that feedback. And doing the think independently, talk to other people, go back and think independently also seems to be a good way of getting the best out of your experts. And that's it. Thank you very much.
Fantastic. Thank you very much indeed, Anca. And I love that that recognition of the power of the expert, sometimes perhaps perverting the results potentially, and dealing with bullies, and the plain language which is being used, and also the continuing learning that's available to the experts as they go through the different iteration also dawned on me. It's sort of a bit Bayesian in the sense, in the spirit of Bayesian as well. We've got a couple of extra questions coming online now. Let me ask this one from Maji. Maji asks, how would the concept as far as reasonably practical fit into the model?
I'm not sure I understood that. Can you maybe?
Yeah, so I guess this ties. Maji, did you want to ask this question in your own words so that I do it justice, and that way I'm not paraphrasing your question? If you're online, Maji. Yeah, please.
So the question was in the context of, often when we do work in major hazard facility work, for example, and risk assessments, there's a trade-off in terms of finding a solution in terms of what can be actually afforded by the organisation. So there's this trade-off that's often discussed with regulators in terms of as far as reasonably practical, rather than going to the nth degree and trying to solve a problem. So I'm just wondering, how does that fit into, or how is that considered in the model that you were discussing?
So I'm not sure I understand exactly what you mean, but I will try and answer. And if I go off the rails, you just stop me and tell me to come back. So as far as reasonably practical is, in a way, you're constantly doing that from the beginning until the end of your modeling exercise, in terms of once you decide on a model and you see what sort of data you would need to parameterize that model, you will go back and forth and realize that's not going to be practical. That's not going to give you, you won't have time to do it. You won't have the resources to do it. Let's go another level of abstractization, of modeling, a generalization, and then see what available resources you have there. And it's the same in terms of the expert judgment. You would, for me at least, it's very tempting when we parameterize a model to think that my experts can answer hundreds of questions. Surely they can do it. They have all the time in the world. But then you realize that is not practical. And then you reframe your questions, you reframe your modeling such that you ask something that is reasonable. So it comes in at different levels and stages. It's not baked in a certain protocol. It's baked in the way you do your modeling. Does that make sense?
Yeah, it does. Thank you.
Thanks, Margie. I've got a comment from Bhavin, which is interesting as well. I don't think it's a question. Back in 2004, I had to transform tsunami vulnerability into development index development based on demography and social wealth. It was very tough. I managed to do it with weight to coastal villages. Is there any methodology in including these types of risk into identifying development projects to uplift social settings and livelihood? So I think there's a comment in terms of Barman's experience, but also a question at the end of that.
That does indeed sound very tough. Sorry, I'm just rereading the question. Yeah. It does sound very tough. And it sounds like if you were to have enough time, you would build, being a modeler, I would build a model for that. I will build a model and I will try to go to experts to talk about it. And in this sense, experts is not always well defined. It's unclear what sort of expertise the experts should have. So in that last bit of question that you have there, the experts would be the communities that you would like to work with. And we've done semi-structured or structured elicitations with people from the community. And it's very challenging because you have to redefine the questions in a language that they that they're familiar with, that they understand, that they can answer in a coherent way. And it's challenging for us, but it's absolutely beautiful if you get the message across. Working with communities is very rewarding, and it's very rewarding to actually be able to put that in a context that will actually change something that decision makers will act on. It is possible.
Fantastic. Thank you for that. Nice comment from Jocelyn as well. Fantastic summary of lessons learned. So applicable as well. Steph Buller has said we have same in the UK for defensible decision-making purposes. And that was something, again, that I can see these high-profile, large public health or defense types of decisions where perhaps an increasing level of skepticism is coming to some of the traditional experts. Read consultants in some of that as well. And another question is, can SEJ integrate effectively with dynamic risk assessments? We might leave that as the last question as we're overdue. Thank you.
If by dynamic risk assessments you mean dynamic in a temporal way, then they will have to be, it's actually quite nice to have an elicitation that you would repeat in time for the next time step, because you build on something that you already know. So you have a base rate, just like we had for one of the elicitations. And given this, it will be a lot easier for your experts to project for the next time step. If this is what you meant by dynamic, then absolutely. But I don't know.
Is that right, Brett? Do you want to just clarify? That's in the temporal sense?
Yeah, yes, it is. It's probably more so around those immediate sort of risk assessments that are occurring at that point in time. But it obviously then takes time for people to record those assessments post and to be able to build upon. So I was just trying to clarify whether or not they would integrate, and yeah, I can see how they would.
Terrific. Thank you very much indeed. We've done our questions and comments. We're over time, but back to you, Teresa. Thank you so much, Anca.
So thank you very much, Anca. Thank you, everyone online. If possible, could you turn your cameras on? We are going to have a team photo. So thank you very much for attending, especially after a day of work or early in the morning or in your lunch break. So what we'll do is we'll set up the screen. That way we get everybody's face in, and we're going to take a photo. Okay, so Shri, let me know when we're good to go. All good, Paul?
I think we're about Shri, just waiting for the confirmation from our photographer in the background. Yep. All good. Good to
Lovely.
go. It's free leave. Thanks, everybody.
Thank you. Have a wonderful
Thank you for
evening.
coming along. Thank you, Anca.
Thank you.